Alright guys, welcome. Today we're going to be doing a lesson on inverse functions. So we're going to, basically the objective, if you will, is to be able to determine the inverse of a function and determine whether it has an inverse and verifying that given functions are inverses of each other. Alright, so let's go ahead and introduce functions. So a function is a special type of relationship between two or more variables. Usually you have an input and an output. So in this case, a function is a special relationship between variables, usually input and output, in which each input has a single output. So to determine whether something is a function visually or graphically, we use what we call the vertical line test. We'll show you how that looks like in a little bit, but it's a very simple test to determine, like given a graph, if something is a function. We use function notation to denote functions, so like f of x, g of x. So in this case, x is sort of like your input, is your input variable, and f of x, your f is your output. Also known as y. So we usually use y as f of x and x as the input. So this is asking, is the following relation a function? So for part A, you're looking at ordered pairs here, x, y. So the inputs are the first coordinates in the ordered pair, and then the outputs are the second number in the ordered pair. So for each given input, do you have a single output? Well, if you look at this guy, if you look at these two, you have the same input leading to two different outputs. So therefore, this is not a function. Because remember, the definition is that for a function is that each input has to have a single output. It can't have different outputs. So this is not a function. Since x equals 1 has multiple outputs. Y is equal to 2 and y is equal to 3. All right, now look, part B, we're looking at the same thing here. So here we have two of the same input leading to two different outputs. So like the same input leading to two different outputs. So this is also not a function. If this were a 3, for instance, then this would be a function, because you would have different inputs leading to different outputs. So you would have different inputs leading to different outputs. But in this case, it's not a function. All right, so now for part C and D, if you look, we're looking at it graphically. So this is where we use the vertical line test. Okay, so this is where we use the vertical line test. So what we do is we draw a vertical, where we basically, use a sweeping vertical line to see if the graph crosses at more than one point on the line. Here the graph only crosses that line once. If you were to do another vertical line, it only crosses it once, and so on. So that's the vertical line test. So if it only crosses it at one point, then that means it passes the vertical line test. Okay, so in this case, this is a function because it only crosses it at one point on the line and not more than one point. So it passes the vertical line test. So we'll say passes the vertical line test. So that means it's a function. It only crosses at one point. If you look at D, well, if you put a vertical line through that, well, it crosses it at more than 1 point. It crosses it at 2 points, to be exact. So it does not pass the vertical line test. So it's not a function because it fails the vertical line test. All right, so that's vertical line test, and that's how to determine if something is a function. Now, that's just a refresher of what you may have done before. So now what we're going to look at is we're going to look at inverse functions. So what is an inverse function? An inverse, the word inverse means that, you know, you're doing the opposite or the reverse of something else. So in this case, an inverse function essentially means the opposite of another function. So it's basically, you know, you're doing the reverse of the other function. So in other words, the inverse function essentially undoes the function. So undoes another function since it does a reverse. So for example, if you added a value to a function, then reversing it would mean that you would have to subtract by that same value. And now essentially does the opposite, the reverse, and undoes the function. So the general rule is that inverse functions do the opposite thing in the opposite order. One quick way of finding the inverse of a function is literally to swap or switch the x and the y values. And that is actually an easy way of doing it for given ordered pairs. If you were to be given a graph and you want to do the inverse and you want to determine it or graph the inverse, you would swap the x and y values just like we did before, and then graph the function. You'll notice that when you do this, you end up having a graph that is a reflection about the line y equals x. So in other words, you are reflecting about the line y equals x. So we'll show you how that looks like. So let's look at number 2. So we want to determine the graph, or determine or graph the inverse. So here we're given a relation, and we want to determine whether it's an inverse. So or determine the inverse. So since this is the x value, this is the y value, you want to swap the x and y values. So your actual inverse is now going to be 27, -3, -8, -2, -1, -1, 0, 0, 1, 1, 8, 2, and -27, 3. And that's the inverse of that. Pretty simple. So you're literally inverting or swapping the x and y values. So for part B, it's the same thing as part A, except you're given a table instead. So now we're going to swap out x and y. So now we have, so x is 0 and y is -1, so it's going to be -1, 0, 4, 2, oops, that should be 3, 3, 4, and 0, 6. All right, so now let's do the graph. So if we're given a graph, remember that you're going to basically swap the x and y values, or basically graph about the line y equals x. So let's show you in this simple graph. So if this is the point 1, 1, and this is the point 2, 4. So we swap the x and the y value, and then we plot that. So this will be 1, 1, so it's still going to be here. This is going to be 0, 0, it's still going to be here. This is now going to be 4, 2. So this is 1, 2, 3 and then 4, so around here. And so now we have 4 and 2, and then we graph that. So when we graph that, try to do that best I can here. Oops, let me go back here and erase that. Okay, so there. So that is the graph of the inverse. And then, of course, we have this part here. So if this were -1, 1, then this will be 1, -1. If this were -2, 4, then it would be 4, -2. So 4 and then -2. This should be all the way up here. I don't know. I put the dot there, but it should be over here. 4 and then -2. And then we can graph it. All right, so that's how the graph looks like. That's the graph of the inverse. And notice that it's a reflection about the line y equals x. So if you were to graph the line y equals x, it will look something like this. And so if we were to reflect this part, it'll be a reflection here only if, well, in general, it'll be a reflection here. And notice that this inverse right here that we just drew is not a function because it fails the vertical line test. So sometimes when you find the inverse of a function, it ends up not being a function itself. And we're going to actually talk about that. That's actually the horizontal line test. The horizontal line test tells us if a function has an inverse that is itself a function. And that's what the horizontal line test is for. So now let's go ahead and do this real quick. So if we have, this is going to be 1, 1. This is going to be 2 and 8. This is 2 and 8. It continues over here. So if that's 2, 8, it'll be 8, 2. And this will be 1, 1. This will be -1, -1. And so on. This will be -2, -8. So then if we swap that, it'll be 1, 1. If we swap that, it'll be 0, 0. If we swap this, it'll be 8, 2. So it'll be all the way over here. So if we swap -2, -8, it'll be -8, -2. So let me, just for the sake of space here, I'm going to erase this so that I can draw the other graph. All right, so I'm going to be -8 and -2, so somewhere, pretty far away over here. And so then now we can draw the graph. There you go, and that's how the graph looks like. And then if you can tell, it's sort of a reflection about the line y equals x. This is the line y equals x. So it sort of reflects, about that line. So this is actually the quadratic function, and the inverse of the quadratic function is the square root function. So this is the function that we drew earlier was the square root function. And then the inverse of this is the cubic function. The original function is cubic, and the inverse of the cubic is the cube root. So this kind of shows you visually what's going on. So now it says, does problem 2b pass the horizontal line test? That should actually say 2c. It says 2b, it should say 2c. And this should say 2d. So does problem 2c pass the horizontal line test? So then if you look at it, it actually, if you draw the horizontal line, right, then it crosses it at 2 points. So it actually does not pass the horizontal line test. So, which means that, remember, the horizontal line test tells us if the function has an inverse. If the function has an inverse that is also a function. So right now, we just said that the inverse here is not a function. So which makes sense with the horizontal line test. So this fails the horizontal line test. So the inverse is not a function. It's not saying that the original is not a function. The original is a function, but the inverse is not a function. So the inverse is not a function. If not, is there a way for the inverse to be a function? Well, the only way for the inverse to be a function, and I'll quickly draw it here, the only way for this inverse to be a function is if you basically cut it in half and you have this part of the function, and then therefore it'll then pass the horizontal line test because it'll only cross it once. And if you were to have that being the case, then in that case the inverse would be a perfect square root function instead of being a sideways parabola. So the inverse is a square root function only when you have a restriction to the domain. So this graph has to be cut in half essentially in order for the inverse to be a function. So the only way, okay, so is there a way for the inverse? So you'd have to restrict the graph for x is greater than or equal to 0. So basically for positive x values. If you make the x values positive, then you basically have half of the graph, and then you can do the inverse for it and get a function from it. What about problem 2D? Does it pass the horizontal line test? So if you look at the original function, it does indeed pass the horizontal line test. Let me just erase all this and kind of see it. So, you know, if you were to draw a horizontal line there, it only crosses it once. So therefore, it does pass the horizontal line test, which means that the inverse is a function. So the inverse that we drew earlier, this guy here, is a function because it passes the vertical line test. So these are kind of interrelated to each other. So the horizontal line test tells us if the inverse is a function, and then to tell us if a graph is a function, you use the vertical. So does problem 2D pass it? Yes, it does. It passes. Horizontal line test. So this means that the inverse is a function. All right, so we determine, you know, basically how to, you know, more or less graph the inverse, you know, kind of estimate it, how to determine the inverse, like from ordered pairs. Now we're going to look at determining the equation of the inverse. So to determine the equation of the inverse, you're going to do the following steps. So you're going to basically swap x and y, like we said earlier. In order to find the inverse, you swap x and y. But before we do that, we're going to rewrite the y as f of x. Or I'm sorry, we're going to rewrite, this should say f of x. Rewrite f of x as y. And that's if the problem needs it. So for example, if you had f of x equals 5x, then you're going to rewrite this as y. That's basically what that step is saying. So that's step 1. Step 2, you're going to swap or switch x and y, just swapped x and y. Then you're going to solve for y, and then you're going to change the y to f inverse of x. That's the symbol for inverse. The symbol for inverse. Okay, so let's go ahead and show you that step, so that process. So for part A, you're gonna change f of x to y, so y equals x squared plus 1, and then you're gonna swap x and y together, x and y, switch them. So let me just say that's step 1. This is step 2. then we're going to kind of do step 3. So we're going to switch, we already switched x and y, now we're going to solve for y. So in order to solve for y, we got to subtract 1 on both sides. So we have, I'm going to rewrite this on the left side. So we got y squared equals x minus 1. All right, now we got to get rid of the squared. The only way that we can get rid of a squared is to do the square root. So we're going to do the square root of both sides. However, guys, this is the key note here. When you do this, you need a plus or minus sign here. And the reason why you need a plus or minus is because the square root can have two values. It can have a positive value and a negative value. So this is what this bullet point actually tells you right here. So every time you take the square root of both sides, you must include the plus or minus signs. And here's the example. So because 3 squared is 9, but also negative 3 squared is also 9. So when you take the square root, you're going to have 3 and negative 3. You're going to have positive or negative value here. So therefore, you have to be careful to do the plus or minus when you do the square root. So in this case, we have y equals plus or minus square root of x minus 1. And a way to kind of show you what's going on, so the plus square root version, so plus square root is basically, so if you look at the original problem here, the positive square root is this part of the inverse. This is the positive version. The negative square root part is basically this part of that graph. So in order to get a function, you need only one of those parts. So that's the plus version, that's the minus version. So to kind of give you a visual of what's going on, why do we have a plus or minus version? So now let's do part B. So we're gonna, let's convert y to f inverse. So that'll be our final step. So we got f inverse is equal to plus or minus square root x minus 1. Okay, so that's plus or minus. Since now let's say that we want x to be greater than or equal to 0. In this case, we want to look at the positive values. So therefore, we're gonna look at, and this is in the homework. This is why I'm mentioning this in the homework. It'll in one of the problems, it'll say x is greater than 0. So then you'll say that this is going to be positive square root of x minus 1. If it said x is like less than 0 or the graph is less than 0, then you would kind of look at this part. So it'll kind of tell you, which one to look at. I'm sorry, it'll say, it won't say x is greater than 0. It'll say, I'm trying to remember how it'll tell you. The problem will kind of say, like graph is positive or something like that. Sometimes it'll kind of mention it in a certain way so that you know which one to take, the positive or negative version. All right, but just keep remembering, in general, you do plus or minus, and then if it tells you which one to use, then you use that version. Now let's look at part B. So in this problem, we are going to, again, change f to y, then swap x and y. Now you're going to add 5 to both sides. You're going to solve for y here, so now you got to get rid of everything except for the y. Now you got to divide by -2. So now you're left with y to the third equals x plus 5 over -2. And then the only way to get rid of the cube is to do the cube root of both sides. That's the only way to getting rid of cubes is doing the cube root. Okay, so we have y equals cube root of x plus 5 over -2. All right, in this case, we do not need a plus or a minus version, simply because it's all one continuous graph. So whenever you do cube roots, you don't need the plus or minus. You only need plus or minus for square roots. So square roots are the weird ones, and then cube roots are the regular ones. Okay, so square root is weird because you have to do the plus or minus, and you have to do it for the even. If it's even, then you have to do it. If it's odd, like 3, then you don't have to do it. All right, so as we mentioned here, the square root function is the inverse of the quadratic function as long as you restrict, so when you restrict. Domain. Okay, so as long as you're restricted, then you're good. So for example, x is greater than or equal to 0, or x is less than or equal to 0. And then it says the cube root function is the inverse of the cubic function. So that's actually what we did here, right? So this was a quadratic, and we got a square root function. This is a cubic function, we got a cube root function. So now part C, we're going to do the same thing here. So y equals 110 x to the 5th, swap x and y. So now we got to multiply by 10 on both sides, because right now this is dividing by 10. So we need to multiply by 10. And that's the only way that you can get rid of that guy. So we got 10x equals y to the 5th. Now you got to get rid of the 5th power. Kind of like we got rid of the 3rd power by doing cube root, we can get rid of the 5th power by doing 5th root. So that's it. Y equals the 5th root of 10x, and there's nothing else to it. And then of course we gotta, replace the y with the f inverse, and then we're done. All right, so now we're gonna look at this guy. Y equals 3x minus 1 over 5. Swap x and y. So now you got to multiply both sides by 5 to get rid of that guy because it's dividing. Now you got to add 1 to the other side. So we got 3y equals 5x plus 1. Now we got to get rid of the 3, so we're going to divide by everything by 3. Or we can just write it as 5x plus 1 over 3. I'm just going to do the whole thing over 3. And then change that to f inverse. So our final answer is f inverse equals 5x plus 1 over 3. All right, and that's all there is to it, to find the inverse. So now if you were to find the inverse, now that we know how to find the inverse, what you need to know is, the next skill is, you need to determine if given two functions, how do we know that they're inverses of each other? So in order to verify that two functions are inverses, you have to use what we call composition of functions. Okay, so like this here, you see this little circle? This is f of x, circle g of x, also known as f of x compose with g of x. And this is f of g of x. So notice that whatever's after the circle is inside the parentheses. So this is read as f composed with g, or f of g of x. So this is normally g of x, so this is f of g of x. And what this means is that you're basically plugging in g into every x in f. Okay, so if you were to do this, then and you were to get x as your value, that would tell you that they're inverses of each other. So let me show you how this works. So these are my two functions. Now we want to know if they're inverses. So we're going to do the two things. So we're going to do f of g of x first. So g of x is x minus 1 over 3, right? So let me rewrite this. So f of x minus 1 over 3. Okay, so now for every x I see in f of x, I'm going to replace it with x minus 1 over 3. So I'm going to replace this guy, I'm going to replace this x with that guy. So we have 3 times x minus 1 over 3. That x gets replaced with that, plus 1. Now notice that the 3's cancel, so we have x minus 1 plus 1, and then so we have x minus 1 plus 1. And also notice that the 1's cancel, the negative 1 plus 1. So that leaves you with just x. All right, so that checks through. So we're supposed to get we're supposed to get x if they're inverses. Now let's do the reverse. So g of f of x. So we know that f of x is 3x plus 1. So for every x we see in g, we replace it with 3x plus 1. So we have x minus 1, so that becomes 3x plus 1. That gets replaced right here. Minus 1 over 3. Minus, oops, let me erase that. Minus 1 over 3. So this is the original x, okay? That original x got replaced with 3x plus 1. 1 and negative 1 cancels. So we have 3x over 3, but 3's cancel, so it leaves you with x. So that means that these are inverses. All right, so so let's go ahead and write that out. F and G are inverses. All right, let's go ahead and try for this one. So see how they're, this should be a squared right here. My bad, guys. X squared minus 1. So see how they're restricting us right here, x is greater than 0? That's just telling us that we're only looking at the part of the graph. And the reason why is because we have a square root. And remember what I mentioned about square roots is that you have the plus or minus version. So if you only have the plus version, then you have to restrict it to positive numbers for x. All right, so now so now for this guy, we're going to, we're going to swap, or we're going to, not swap, we're going to use composition. We're going to compose. So f of square root 2x plus 1 plug that into this guy. So we're going to plug this in to x squared, to x. All right, so we got this guy in x, and then it gets squared because we had the squared there. Okay, so we're going to replace x with square root of 2x plus 1, but then it's squared minus 1 over 2. All right, now that gets rid of the 2x, the square root of 2x plus 1. So now this becomes 2x plus 1 squared. The squared and the square root cancels because they're opposite of each other. So now we have 2x plus 1 minus 1 over 2. 1 and negative 1 cancel. So we have 2x over 2. Notice that the 2's also cancel, so it leaves us with x. That's exactly what we want to show that they're inverses. Now let's do the opposite, the reverse. So g of f of x. So we have g of, now we're going to replace f of x with x squared minus 1 over 2. All right, so for every x we see here, so this x is going to be replaced with that guy right there. So it's going to be replaced. So we have square root. Now x is going to be replaced with that. So x squared minus 1 over 2. Don't forget we have a 2 in front of that x. So I'm going to put that 2 in front of that right now. 2x, and then that x got replaced. And then plus 1. So now the 2's cancel here. The negative 1 plus 1 cancels. Now we have square root of x squared, which cancels. And since we're looking at x as positive, then it's just going to be x, okay? Since we're only looking at positive x values. Like we said, x could be positive or negative depending on, because it's a square root, but we're only looking at positive x values, so therefore it's x. All right, and that's how you find the inverses. That's how you verify inverses.